In this question, we're given the diagram of a rectangular prism, we're given the volume of the prism, and we're given the width of the prism. And we have to determine which of these lengths will give us the smallest height. Well, since we're given the volume, let's put down the equation for the volume of a rectangular prism. And that is volume is equal to the length times the width times the height. Next, let's look at what we're given. So the 216 centimeters cubed is the volume. The 6 centimeters is the width, and then we don't have the length or the height. So let's put what we do know into the formula. So 216 centimeters cubed is the volume. Length we don't know. Width is 6, and height is we don't know. Then let's simplify this as much as we can. So what we can do is divide both sides by 6, and we would get 6 goes in there once, goes in there 36 times. So we would get 36 equals to the length times the height. Now we're asked to find the smallest height. So let's isolate this equation for h. So to do that, we'd divide both sides by L. And what we would get is the L's canceling, and then we would get 36 divided by L, or the length, equals the height. Well, next, one of the things we could do is set up an ordered pair table looking at the length versus the height. And they give us the lengths that we want to look at, so let's put those in here. We've got 3 centimeters, 6 centimeters, 12 centimeters, and 18 centimeters. So if we put 3 centimeters for the length into our equation, we'd get 36 divided by 3, and that would give us a height of 12. And we can keep going. So we've got 6 centimeters for the length, plug it in. 36 divided by 6 would give us a height of 6 centimeters. Again, 12 into our equation. 36 divided by 12 would give us 3. And then finally, 18, if we put that into our equation, 36 divided by 18 gives us a height of 2. So when we look down our list of options, we can see that the smallest height occurs when the length is 18 centimeters. And that makes sense because when we look at our equation here, we can see that h and L are inversely proportional. That means as L increases, h will decrease, and vice versa. And so the correct answer is D. And again, the reasoning being that you would expect the height to be the smallest when the length is the largest.